Hi, I'm Shishir. I work at ThoughtSpot, and I work to improve developer productivity, primarily focusing on build and CI. We have a small talk. We'll discuss. So basically, I'll start with a seemingly unrelated question. What do you want in life? Peace, happiness, money, and maybe faster builds, right? So yeah, so this is a small improvement that we made, and that paid disproportionate dividends, and we'll discuss that. And just to be sure, this is not to be confused with persistent workers. So the problem statement is, how do we leverage incremental builds in CI and per commits, right? So for those, I'm sure most of you, almost all of you would be familiar, but for those who aren't familiar, clean build is where you build everything from scratch, whereas incremental builds reuse already built artifacts or already completed actions. So in case of Bazel, you can also, often in case of incremental builds, you often reuse the running Bazel server process. So that makes, these two things make the incremental builds faster. And we wanted to leverage that in our CI because when developers build locally, they often build incrementally. They don't run Bazel clean, and they run one Bazel build after the other, right? That doesn't happen in CI, at least not in our case. We had to start a new container, check out code, start a new Bazel build afresh. So what we did was we had our on-prem Kubernetes farm where we were running all these builds. We created these long-living Jenkins Kubernetes pods that we registered as Jenkins build agents. And these are what we call persistent pods. And we use stateful sets for implementation that helped us, that really made our lives easy, right? The lifecycle management became really easy. You can scale down or scale up the number of pods depending on the number of incoming builds. And updating the pods and all that, that became really simple. We also had local disk cache as persistent volume. This was our first layer of caching. And since the artifacts are present locally, this meant really low latency. So this is the rough architecture where we have our on-prem Kubernetes cluster, where we have provisioned a bunch of so-called persistent pods where Bazel is running. And this can work with, this can interact with the Bazel remote cache, even with remote build farm, a remote build execution farm, and it obviously registers as Jenkins agent. So so benefits, basically fast incremental builds in CI and pre-commits. And in terms of headline numbers, we saw about 40% reduction in average build and test time. And this is average, and which is significant because we did not make any change to our Bazel specific files. And this was really some change in how we run things. And in extreme cases, right, best case, we saw 80% reduction, and in CLs or PRs that have a large amount of change, a significant change, we saw less pronounced numbers. And so the case with CI, where we have a lot of changes. So one challenge that we faced while we had multiple such pods was finding the right pod for the incoming build. Now, different builds had different pods that they had in their previous builds built on different SHA. Now, what you want to do is minimize the amount of work that you do. Right. And we had this other problem of supporting multiple branches, which were often out of sync and had significant git difference between them. And obviously, the git difference between incoming Bazel builds. So to address these, we started simple. We had branch-specific pods so that all the changes that belong to a single branch, they come to a family of pods that are reserved for that branch. And we rebased every CL or PR. That meant that the PR was close to the head of the branch, and the diff between different incoming changes were minimal. So we want to, and now we are exploring this further. Yes, this is work that's still going on. So we are testing different heuristics to select the optimal pod to minimize the work done for incoming builds. So we are looking at git diff. So suppose we have a bunch of pods. Now for each of those pods, you have git sha from the previous build. Now you can run git diff for the incoming build and see, okay, on this pod, the number of files that are changed, but the difference between these two shas is minimal. Maybe that's the pod I'll go for, right? Or you can go a step further. You have all the Bazel relevant files. From that, you can derive all the Bazel targets that you have modified between these two shas. And based on that, you can run your Bazel query to get the reverse dependency cover of all the modified targets. And that can serve as a metric. That number can serve as a metric to identify the the optimal pod for your build. But these are all heuristics. So there are cases when the simple logic doesn't work, and we are looking into it, how to modify or fine tune it even further. That basically is it. If you have any questions, yeah. Sorry.
Yeah, so maybe two thoughts, because we are trying to achieve exactly the same currently. The first question is, did you consider usage of Jenkins Kubernetes plugin? Because in this case, you don't need a stateful set anymore. And as far as I remember, you can reuse pods. So that basically means that Jenkins fully manages working pods for you.
To be honest, we did not. So we did this about 2 years ago, and we did not look into that. But I think, yeah, now that you told me, I'll look into it. Thank you.
And maybe another thought. So basically, we've got pretty much the same use case that we need to support, well, sort of incremental builds for different branches. But what we came up with, we're just spawning different output-based directories. That means that you're not starting Bazel server over and over again, but you have like a separate base directory. That means that you can simplify your infrastructure setup because you don't need different pools of pods. But as a downside, of course, if a certain branch build didn't land on that pod before, you have nothing to share. But again, it can, reduce the maintenance effort on your infrastructure side.
Yes. So to go into a bit of detail, yeah, I think that's an interesting idea. Basically sharing the pods and having different output directories for different branches. What we did was rather simple. So we had used Jenkins labels to label the pods, and that ensured, because some of these branches were really busy, so they had incoming builds all the time. So the usage was never a problem. We already all these pods were really busy. But I think, yeah, that's an interesting idea to explore, having basically common pods and having different output branches. Yeah.
Right, we had more questions.
Did you ever face instances of pod poisoning or like cache poisoning? If some developer pushes a bad PR and they've poisoned the cache, what do you do then?
Yeah, the cache poisoning was a common case, and cache poisoning in general is basically, it can happen with remote cache as well. So that is a separate thing that we did. Basically, we have tools that make sure that your local environment variables that are specific, they don't come into cache. And so we have a bunch of checks that we run. But in this case, pod going bad is what we call it. So we couldn't find a good solution. So what we did was, if you see any symptoms, you delete the pod and pod comes up. To make sure that we don't check in bad code because of this, because of your CI and pre-commits running in these pods, we have something called branch sanity or master sanity, where your master branch runs the same set of tests on a clean slate. So you batch a bunch of CLs, maybe 30, 40, or 100 CLs. And these are daily runs that happen. And these happen on a clean build on a new pod. So, yeah.
All right, we still have some more time if there are more questions.
Or I can go on to the most important slide.
All right.